On the 31st of December 2014, the UK government implemented a charge on plastic bags in an attempt to reduce the rising use of these bags and the environmental impact that this has. N years after the charge was implemented, the government targeted for the number of plastic bags used to be modelled by the following equation. X equals 7.6 minus 0.2 times n minus 2 all squared, where X is the number of plastic bags in billions used during the preceding year. So let's just talk about that equation a little bit. So X is the number of plastic bags used in billions. N is the number of years after the charge was implemented, which was the 31st of December 2014. So N is the number of years after this date. So on the 31st of December 2015, N would be 1. On 31st of December 2016, N would be 2, and so on and so on. Right, part A. Calculate, according to the model, how many bags were used in the year ending the 31st of December 2014. Well, notice that's the start date. That's when n equals 0. So if we substitute that into the formula, we get 7.6 minus 0.2 times 0 minus 2 all squared. So if we work that out, that is going to be 6.8 billion, I think. Let me just double check that. Yeah, that's 6.8 billion bags. Part B finds the year which the bag usage was expected to be at its highest. So let's look at this model in a bit more detail. There's a reason why it's been written like this. This is in the completed the square form. Completed the square form allows us to see what the maximum or minimum would be, depending on whether it's a positive x squared or a negative x squared. So looking at this formula, I can see that it's going to be a maximum because of the minus n squared. And I can see that that maximum is going to occur when n is equal to 2. And that maximum would be 7.6 billion. Let me just explain that a bit more. So if n is 2, then that means that n minus 2 would be 0. Therefore, 0 squared would be 0 times the 0.2, which would be 0. So 7.6 take away 0 is 7.6. That is the maximum that could possibly be. It cannot be any higher than that. There is no value of n that I could substitute in here that would make this bigger. If I substituted anything other than 2, if I substituted 2.1, then when I take away 2, it will not be 0. When I square it, it will not be 0. It will be bigger than 0. When I times it by 0.2, it will be bigger than 0. And therefore, I will have to subtract something from 7.6. So therefore, it will be less than 7.6. Anyway, the point is that the bag usage is expected to be at its highest 2 years after it starts. So that's going to be at the end of 2016, on the 31st of December 2016. Part II, how many bags were predicted to be used in that year? Well, like I said, 7.6 billion bags. Part C. In the year ending 31st of December 2018, okay, that's n is 4. That's 4 years after 2014. In that year, 7 billion bags were used. Evaluate whether the government were meeting their target at this point, justifying your answer. Okay, well, let's see what their target is. Let's see what the model would be when n is 4. And then we can compare that to the 7 billion and see whether they were successful or not. So x equals 7.6 minus 0.2 times n, which we are looking at that being 4, minus 2 all squared. So if we work that out, we find that is 6.8 billion. So according to their model, they targeted only using 6.8 billion bags, but they actually used 7 billion. Therefore, they did not reach their target. So targeted 6.8 billion. So they only wanted to use a maximum of 6.8 billion bags, according to the model. But they used more. They did not reach their target. Right, final part of the question, part D. Explain why the model would not be valid in 2025. Okay, well, let's think about that then. 2025, that would be n being 11. That's 11 years after 2014. Well, what's the problem with the model when n is 11? Let's have a look. What would happen? So x is 7.6 minus 0.2 times 11 minus 2 all squared. That gives a negative. And you can't have a negative number of plastic bags. So explain why the model will not be valid in 2025. Model predicts negative bags being used in 2025, so is not valid. And there we go.